Hello, welcome to this week's video about gradient descent. This is week 2's topic, and so through 3B1B's video this week, we learned that through the use of handwritten digits, a network can take inputs in, which are the pen strokes, and then produces an output deciding whether it's the digit 0 through 9 based on what input was given to it. And there is the use of weights and biases that help connect these neurons together, and they ultimately help the machine make a decision. So costs. What are the cost functions of machine learning? Cost functions measure how bad something is. I guess I kind of thought about it like how much something costs when you're in the real world and you want to buy something. Like, you're not going to want to spend too much money on one thing because that's bad. So kind of the same thing with machines. If spitting out a certain piece of information is too costly, then it's not really good information being put out. So the machine essentially takes in 13,000 parameters, and the cost is calculated by the squares of two digits separately, subtracted from each other. And it's the actual output activations minus the desired output activations. And let's say we set a correct answer to 1 and an incorrect answer to 0. And so the lower the cost is, that means the network is definitely confident and it is providing accurate answers. And if a machine has a high cost, that kind of means that it's really confident, but it's usually wrong, which is not a good sign, and it kind of tells us that that is a confused network and it kind of doesn't know what it's doing yet. So in order to minimize cost, we could do so through learning. Guiding a network through learning helps us to minimize the cost and leads to less random outputs on training data, so we don't get sporadic replies that don't make sense. And obviously that's done through learning. Kind of crazy but logical at the same time. And there's also a tool called gradient descent we can utilize for the machine, and that helps us locate the minimum of the cost. And the algorithm essentially becomes randomly initialized with weights and with biases, and they can be adjusted and tweaked in order to kind of sway the pendulum in a direction where the cost is reduced.